Number 1, there are 5 red, 10 blue, and 8 green marbles in a bag. June picks a marble and does not replace it. Then she picks another marble. What is the probability that both marbles are red? And this comes from lesson 83. It's important to note that she does not replace it and that both marbles need to be red. So let's first start. We can see that there are 5 red marbles to choose from and a total of 10 plus 8 plus 5, 23 marbles. So she has a 5 in 23 chance of getting a red marble on her first draw. If she pulls out a marble and does not replace it, when she reaches in to grab another marble, there are only going to be 22 marbles to choose from. And there will no longer be 5 red marbles, assuming she got a red one on her first draw. There will now only be 4 red marbles. So we need to make a note of that for our second probability. And then we multiply these two together. So 5 times 4 is 20. 23 times 22 is going to give us 506. I know I can reduce this probability by dividing both of these by 2, and that'll give me 10 over 253. And that is your answer. Number 2, this is from lesson 79, and they want us to solve this equation for n. So if you notice, this is our slope-intercept formula, y equals mx plus b. And we want to get m by itself. So that means we need to get rid of the x, and we need to get rid of that b also. We're going to do this just like we would any other equation. We're going to start with the b, and since it's plus b, in order to get rid of it on the right side, we therefore need to subtract it. So we're going to have plus b and then minus b. And remember, we can't just do something to one side of the equation. We have to keep it balanced. So therefore, we're going to have to subtract b from the left side too. So now we write what's left. The b's cancel each other out on the right-hand side. Now on the left side, we have y minus b. And notice that those are two different terms. So we can't combine those, so we just have to write them next to each other. Y minus b equals, and on the right side, we just have our mx. Now we have to get rid of the x. Notice that the m and the x are being multiplied together. So to undo that multiplication, we need to divide both sides by x. So let's divide the right side by x, and those will cancel. And now we'll divide the left side by x. And again, we can't combine any of these. Y, b, and x, none of those are like terms. That's how we just have to leave our answer. We cannot simplify this anymore. So we have y minus b over x equals m. Number 73 from lesson 64 and 72. We need to convert 255 gallons per hour to quarts per minute. So we actually are using 2 unit multipliers because we have to convert gallons to quarts, and we're also converting hour to minute. So we need to start with what they give us, 255 gallons per hour. So 255 gallons per 1 hour. Now I could either convert gallons to quarts first, or I could do hours to minutes. It doesn't matter, it's just whichever one you want to choose. So I'm going to do hours to minutes, so I need to multiply it by the correct unit multiplier. So I could either do 1 hour over 60 minutes, or 60 minutes over 1 hour. However, since I want to cancel out hours, I want to make sure that my unit multiplier has hours in the numerator, so that the 2 hours can cross cancel. So 1 hour over 60 minutes. So my hours now cancel, and I could either multiply this by my second unit multiplier, or I could just go ahead and simplify this, which I think I'm going to do first before we start canceling out gallons. So 255 gallons times 1 is going to give us 255 gallons in the numerator. And in the denominator, we have 1 times 60 minutes, so it's 60 minutes. Now we need to convert gallons to quarts. So I can look at my 2 unit multipliers. I could either have 1 gallon over 4 quarts, or 4 quarts over 1 gallon. However, since my gallons are in the numerator, I want to choose the unit multiplier with gallons in the denominator, so I make sure that they cross cancel. So I'm going to multiply 4 quarts over 1 gallon. And now my gallons are canceled, and now I multiply across. 255 times 4 quarts is 1,020 quarts over 60 minutes times 1 is 60 minutes. And now I don't want to do it out of 60 minutes, so I needed to divide 1,020 divided by 60, and I get 17 quarts per 1 minute. Number 4 from lesson 31 and 33, and they just want us to simplify. So we have 5x squared minus 2x squared plus 3x. So first thing I notice is there are some subtraction signs. So I want to get rid of those. I would rather have addition than subtraction. And remember, we can always change a subtraction sign to addition by doing our add a line, change the sign. Add a line, and we change the sign of the term right to the right of it. So that 2x, we change the sign so it becomes a negative 2x. Add a line, change the sign. So now we have all addition, which makes this a little bit easier to work with. With addition and subtraction, we can only combine like terms. So if you notice, I have an x squared and another x squared, and then I have a negative 2x and a plus 3x. So I can only combine those that have the same variable and exponent combination. So for example, the 5x squared and the negative 2x squared, those are like terms, and I can combine those. And I only want to combine the coefficients or the numbers in front. So I have a positive 5 plus a negative 2. When I combine those together, it gives me 3x squared. Now let's look at our other two terms. We have a negative 2x and a positive 3x. Since they both have the variable x, they are like terms, and I can combine them. So we have a negative 2 and a positive 3. When those are added together, it gives me a positive 1. So we just put plus x. I don't need to put the 1 in front of the x because it's implied that that's a 1 in front of there. And that is as far as we can go. We cannot combine these two terms because they are not like terms. Number 5 comes from lesson 77, and it says to solve and graph on a number line. So we have 5 minus 2x is less than 9. Now, this is just like any equation. We have to isolate x on one side of the inequality, and we do that just like we would with an equation. We use our inverse operations to move numbers from the left side over to the right so that we get x by itself. Now, one thing I do want to point out is I've already noticed that it's a less than sign. And so I know when we graph this on a number line, it's going to be an open circle. I'm going to start by subtracting 5 from the left, because 5 minus 5, it'll cancel the 5s out on the left, which is exactly what I want. But remember, everything I do to one side, I have to do the other. So I subtract 5 from the right side of the inequality too. And our 5s cancel out on the left. So we're left with minus 2x is less than 4. Now we need to get rid of the negative 2. So since negative 2 and x are being multiplied together, the opposite is division. So we are going to divide negative 2x by a negative 2. But then we do it to the other side also. So our negative 2's on the left are going to cancel out, and we'll just be left with x. On the right, 4 divided by negative 2 will leave us with a negative 2. And notice we divided both sides by a negative number. So that means we have to flip our inequality sign. So we now have x is greater than negative 2. Now we need to graph the solution on a number line. So here's our number line. I always like to start with 0 and then do a few numbers over on the right. So 1, 2, 3, 4. And then some on the left, negative 1, negative 2, negative 3. So since x is greater than negative 2, that means we need to put an open circle around negative 2. And then our solution is all numbers greater than negative 2. So that means I need to have my arrow pointing to the right to show all numbers greater than negative 2. Number 6 from lesson 82. Sketch a graph for this line. 5x plus 2y equals 10. So for this type of equation, the easiest method would probably just be to find our x and y intercepts. And we can do this, if you recall, by making our x-y t-chart. So we have x and make our t and then our y. And then we're going to put a 0 in for x, and we're going to solve that and find out what y will be when 0 is x, and that'll tell us our y-intercept. And then we can also put in a 0 for y and solve for x, and that'll tell us what our our x-intercept is. So let's go ahead and start and try to plug in x for 0 and figure out what y will be. So I'm going to go back to my original equation, 5, and then I'll plug in a 0 plus 2y equals 10. Now we know 5 times 0, that's just going to cancel out. So we have 2y equals 10. Divide both sides by 2. And we get y equals 5. So there's one point we can go ahead and graph. Now let's plug in 0 for y. So 5x plus 2 times 0 equals 10. 2 times 0, that'll just cancel out, so it's 5x equals 10. We'll divide both sides by 5. So we have x equals 2. So 2, 0. So now we have 2 points, and that's all you need in order to graph a line. So first, let's graph that y-intercept, 0, 5. So x is 0, but y is 5, so I need to go up 5 and put a dot there. And next, let's do 2, 0. So I need to go x2 and then y is 0. So we're just going to put a dot on the 2. And now I need to connect these dots with the best I can with a straight line and put arrow showing its extends in both directions. For number 6, it's from lesson 82, and it wants us to sketch a graph for this line. So there are 2 ways to do this one. First way is, if we look at the formula, it's 5x plus 2y equals 10. That is not in slope-intercept form. So we could rearrange this formula to put it into slope-intercept form so we can easily see what the slope is and what the y-intercept is, and then graph it from there. So if you remember, our slope-intercept form is y equals mx plus b. So that's what we want to rearrange this formula to look like. So we have 5x plus 2y equals 10. So I want to first get this 5x and move it from the left and bring it over to the right side. So in order to get rid of it on the left side, I need to subtract that whole 5x from the left. So I subtract 5x from the left, and that cancels. And then I subtract 5x from the right to keep my equation balanced. And I'm left with 2y on the left. And now 10 and 5x, I can't combine them because they're not like terms. So I'm just going to have to write them next to each other. I'm going to write it as negative 5x plus 10 because if you recall, slope-intercept form is y equals mx plus b, and the x comes before the constant. Now I need to get rid of the 2 in front of the y. So since they're being multiplied, I need to divide by 2. And I have to divide the right side by 2, and I have to divide each term by 2. So my 2's on the left cancel, and I'm just left with y. And then I'm going to keep the negative 5 over 2 in fraction form because it'll make it much easier to see what's the rise and what's the run. So negative 5 over 2x plus, and then 10 divided by 2 gives us 5. Now we have our formula in slope-intercept form, and I can clearly see our y-intercept is positive 5. So first thing I want to do is go and put a dot on positive 5 on the y-intercept. Now I can see my slope is negative 5 over 2. That means the rise is negative 5, which means I actually go down 5. And then I always go to the right, so I go to the right 2. So we're going to count and go down 5 spaces from the 5 on the y-intercept. So go down 4, 3, 2, 1, 0. And then from there, I go to the right 2. So I put a dot on 0, 2. Let's do one more point. So from 0, 2, I'm going to go down 5 more. So negative 1, negative 2, negative 3, negative 4, negative 5. And then I go to the right 2. So 3, 4. So I can plot another point here at negative 5, 4. And then connect it with a line, and you're done. Number 7 from Lesson 8 and Investigation 2. What are the lengths of CE, EF, and FB? So let's just focus on number 7 first. So looking at line CE, it's a diagonal line, and you can see that it forms a right triangle with sides DC and DE. We also know that 2 of the sides are 6 and 8, and those are called the legs of the right triangle. So we need to find the hypotenuse. And we can easily do that by using Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. Now, it doesn't matter which leg you put in for A or which one you put in for B. You can put them in either one you want. I'm going to start with a squared plus 6 squared equals c squared. And now we just do order of operations. 8 squared is going to give us 64 plus 36 equals c squared. And now add those together to get 100 equals c squared. And now I take the square root of both sides, and I get c equals 10. So CE equals 10. Let's look at EF. EF is just that small segment on the top of the rectangle. Now, since this is a rectangle, we know the top and the bottom are both the same size. You can see the bottom is 23 inches and the top has been cut into 3 segments. You have DE, which is 6, FA, which is 15, and EF, which we're trying to find. So if we add 15 and 6, that gives us 21. So we know if the whole thing has to be 23 inches, then EF must be 2 inches. Now our last side we have to find is FB. So again, this is a right triangle, FAB. We know two of the legs are 15 and 8. So therefore, we need to use Pythagorean Theorem again to find FB. So we have 8 squared plus 15 squared equals C squared. 8 squared is 64 plus 15 squared is 225 equals C squared. And then 64 plus 225 is going to give us 289. That equals C squared. And then to undo that square on the C, we have to take the square root of both sides. So we'll take the square root of C squared and then square root of 289. So C equals 17. So 17 inches. For number 8, we had to find what is the area of trapezoid BCEF, and this is from lesson 75. So first, let's recall what the formula is for area of a trapezoid. 1/2 base 1 plus base 2 times the height. So we start with 1/2, and then we have two bases. If you recall, the bases of a trapezoid are the two parallel sides, not the slanted sides. So EF and CB are our two bases. So I'll plug in 2 for base 1 and 23 for base 2 times our height. And remember, the height is perpendicular to the base, so it's 8. And now we just do our order of operations. So we work in parentheses first. 2 plus 23 gives us 25. And then bring down the 1/2 and times 8. I'm going to do 1/2 times 8 instead of 1/2 times 25 because that'll give me a decimal. And remember, you can do multiplication out of order because it is commutative. So 1/2 of 8 is 4 times 25 is 100, and it's inches squared since it's area. Number 9, what is the volume of this cylinder? This is from lesson 76. So first we need to recall what is the formula for the volume of a cylinder. Well, it is volume equals pi radius squared, which is actually just the formula to find the area of a circle, but we then have to multiply it by the height. Let's plug in our numbers. We'll plug in 3.14, and then we can see the entire bottom is 20 feet, and that's the diameter. So half of that will give us our radius. So our radius then must be 10. 10 squared times our height, which is 20. Now we have 3.14 times 10 squared, which is 100, times 20. Now for me, it's a little bit easier to do 100 times 20 first. So I'll rewrite this as 3.14 times 2,000. And then I can do 2,000 times 3.14. I get 6,280 feet cubed because it's volume. Number 10, what is the lateral surface area of this cylinder? This comes from lesson 85. So again, it's the same cylinder, but this time lateral surface area. So first, let's once again go over what the formula is that we need. Lateral surface area equals 2 pi r, which is the formula for circumference of a circle. However, we then have to multiply that by the height. Let's start plugging in our numbers. So we'll start with our 2 times 3.14 for pi. Our radius is 10, because that's half of 20. when 20 is our diameter. And then we multiply that by our height of 20. I'm going to multiply the 2 times the 10 first. So I have 3.14 times 20 times 20, that's the height. Now I can do 20 times 20, so 3.14 times 400. And then I multiply these two together, and I get 1,256 feet squared since it's area. Number 11 is from lesson 67. Brian saved $14 by buying the shirts for 70% off. How much did he pay for the item? So this is one of those problems where we will use our percent boxes. We will start with the percents on the left side and then the actual amount on the right side. And then we divide our box into 3 different rows. Our top row is always the original, and then the middle row is our change, and our last is our new. So the original amount for the percent is always 100%. The change for this one is 70% because we are taking 70% off of the original price. So our new price is actually going to be 30% of the original price. On the actual side, we have the number 14. That's going to go in the middle row for the change because that's how much money he saved. 14 doesn't represent the original cost or the new cost. So that's the difference in how much he saved between the original and the new. And we want to know how much did he pay for the item. So we are trying to find what the new price is. So we're going to put an X under the new. Now we can set up 2 ratios and make a proportion from using the 2 rows that we have both pieces of information for. So I can pull these numbers out of this box to make my proportion. So for example, I have 70 over 30. And notice I didn't say a negative 70. That subtraction sign over there was just showing that I was just doing 100 minus 70. And then I also have 14 over x. Now I just cross multiply and solve this like a regular proportion. So I have 70x equals 30 times 14, which is going to be 420. Now we divide both sides by 70. Divide 420 by 70. 70s are going to cancel out, so we are left with x equals 6. So that means Brian paid only $6 for his new shirt. Number 12 is from lesson 73. It says a formula for a sequence is a subscript n equals n squared plus 3n minus 1. And they want to know what are the first 4 terms. So for these problems, all you have to do is plug in the numbers 1, 2, 3, and 4 in for n and solve, and you'll have your first 4 terms. So we'll start with a1 equals 1 squared plus 3 times 1 minus 1. So 1 squared is 1 plus 3 times 1 is 3 minus 1. And then work left to right. 1 plus 3 is 4 minus 1 is 3. So our first term is 3. Now we're going to do the exact same thing, but now for the second term. So a subscript 2 equals 2 squared plus 3 times 2 minus 1. So 2 squared is 4 plus 6 minus 1. 4 plus 6 is 10. minus 1 is 9. And there's our second term. Now we'll do the third term. So we have A3 equals, and then we're going to plug in 3 squared plus 3 times 3 minus 1. So 3 squared is 9 plus 9 minus 1, and that's 18 minus 1 is 17. So 17 is our third term. And finally, we will move on to our fourth term. So we have A4 equals 4 squared plus 3 times 4 minus 1. 4 squared will give us 16 plus 12 minus 1. 16 plus 12 is 28 minus 1 is 27. Number 13 is from lesson 84. It says, how much money is 66 2/3% of $42? So this is basically just already set up as an equation. We know of means to multiply, so we're going to be doing 66 2/3 times $42. However, let's rewrite 66 2/3% as 66.6 continuing percent. Because this is just writing it just two different ways. One is saying 66 wholes and 2/3%, and the other is saying 66 wholes and 0.6 continuing percent. Because we know 2/3, when you make that into a fraction, it's 0.6 continuing. Now it's a little bit easier to see how we can turn this into a decimal, because we don't want to multiply by a percent. So remember, to turn this into a decimal, we move the decimal 2 places to the left. So now our decimal is 0.66666 forever and ever and ever, continuing and repeating. And obviously we do not want to multiply by this, because that would be too hard to multiply 42 by a continuing decimal. However, we do know that 0.6 continuing as a fraction is 2/3. So how about we write this as 2/3, and then we'll multiply that by 42. 42 over 1 to make them both into fractions. And we can actually cross reduce here. I know that 3 and 42 can be simplified. So if I divide 3 by 3, I get 1. And 42 divided by 3 is 14. And now I just multiply across. So 2 times 14 is going to give us 28. And it's money, so we'll write $28. And over 1, so we just say it's $28 is our answer. Let's try one more of these. So I'm just going to only change the percent. And we're going to do another one that's a continuing percent, 33 1/3%. Now again, just like the other one, we're going to rewrite this. Instead of 33 1/3%, we're going to write it out as 33.3 continuing percent, because we know that 1/3 is the same as 0.3 continuing. And now we can take this and turn it into a decimal. So we're going to take it from a percent to a decimal, and we do it just like we did the other one by moving our decimal place 2 points to the left. So now we can see our decimal is 0.3 continuing. And again, we wouldn't want to do a multiplication problem with something like that. So instead, we are going to turn 0.3 continuing into the fraction 1/3, because we know that 0.3 continuing is the same as 1/3. Now we can easily take this 1/3 and multiply it by 42. So by 42 over 1, and again we can cross reduce the 3 and the 42. So that becomes a 1, 42 becomes 14, and when we multiply across, we would get $14. Number 14 comes from lesson 50, and they want us to solve for x. Now, we are very familiar with these types of problems. It's just solving for x. However, this one has decimals in it. That's okay. It's just decimals. But we still do the exact same thing when we're trying to solve it. So the first thing I always look for is looking to see if there are like terms that I can combine. And we can. We have two x's on the left that we can combine. Now we need to remember that really in front of that x is a 1. So it's really 1x minus 0.3x. So when we combine those, we're going to get 0.7x because 1 minus 0.3 will give us 0.7x equals 2.1. Now we have 0.7 times x. So in order to get rid of that 0.7, we need to do the opposite, which means we need to divide. So we're going to divide 0.7x by 0.7, and again do it to the other side. And for our answer, we'll get x equals 3. Number 15, it also comes from lesson 50, and they want us to solve for x. It looks like it got a little bit cut off, so sorry about that. It's 1/7 x minus 3/7 equals 5/7. And again, this problem, we're very familiar with doing these. It's just solving for x. However, this time we just have to work with fractions. No big deal. Since we are subtracting 3/7 on the left, we want to add 3/7 to both sides. Our 3/7 then will cancel out because of minus 3/7 and plus 3/7. And then we add 3/7 to the other side. And on the right-hand side, 5/7 plus 3/7 is 8/7. And on the left, we just have 1/7 x left. Now, from this point, we have 1/7 times x. Normally, we would divide because division is the opposite of multiplication. However, we never divide by fractions. We wouldn't do divide by 1/7. Instead, if you think back to your rules, when we divide fractions, we actually flip the fraction and multiply. So again, instead of dividing by 1/7, we're going to multiply by 7/1, or just the reciprocal of 1/7. So we're going to multiply by 7/1, because as you'll notice, that makes it perfectly easy for my 7s to cancel out and my 1s to cancel out. So all I'm left with is x. Now again, if I did it to this side, I've got to do it to the right. So I multiply by 7/1, and my 7s cancel, and so I'm just left with 8. X equals 8. All right, number 16 comes from lessons 27 and 51, and all they want us to do is simplify this expression. So there's lots of different ways that you could approach this problem and different orders you could do it in. So I'm just going to do it one way, but of course you might have another way you prefer to do it. So what I like to start with are the coefficients, 3 and 6. I know I can reduce that by dividing them both by 3, so that's 1 and then 2. So I've reduced those. Next, I look to see if there's anything I can combine on the top and anything I can combine on the bottom. So on the top, I know I have 2 p's. I have one that's p to the 4th, and then I have that other one that's just p. But we really know that it's actually p to the 1st power. We just usually don't write p to the 1st power. So I can definitely combine those. Remember, when we are multiplying, we actually add the exponents. So when I put those together, p4 to the p1st, it now becomes p to the 5th. I'm going to cross off this other p so we remembered that we used it and it's gone. Now I'm going to rewrite this. I like to do this periodically because sometimes it gets a little messy with everything being crossed off and marked off and reduced. So I'm going to rewrite this as 1p to the 5th over 2 p6x2. Now you'll notice I did not write down the x negative 2 on the top. And I did that for a reason, because remember, we do not like to deal with negative exponents. And we can always get rid of negative exponents by moving that whole term down to the denominator, or if it was negative on the denominator, we move it up to the numerator. So we just move it to the other side in order to make it positive. So I'm going to take this x negative 2 and move it to the denominator. So it will become x to the positive 2. And now you'll notice we have two x's on the bottom. We have the original x2 and now we have the new x2 that we just brought down and made it into a positive x squared. So we can combine those because they're like terms. So remember, when we're multiplying, which we're doing here, we keep the variable, we keep the x, but we just add the exponents together. So instead of x2, it's now x to the 4th power, and we're going to cross off that other x because we've combined them now. Now notice we have p to the 5th on the top and p to the 6th on the bottom. So if you recall our exponent rules, when we're dividing, we actually subtract our exponents. So sometimes it's a little bit easier to write out the subtraction. So we do 5 minus 6, and that will give us a negative 1. So this is now going to be p to the negative 1. Notice I crossed off that p to the 6 on the bottom because we combined them and kept it up in the numerator. However, now we have p to a negative exponent. So just like we did with the x's earlier, we have to take that and move it down to the denominator to make it positive. So we have 1 over 2. That p to the negative 1 will move to the denominator, so p to the positive 1. And then we still have our x to the 4th. And we don't need to show p to the 1st power, so I'm just going to rewrite it without that. Number 17, we need to simplify, and this is from lessons 33 and 36. So we have negative 2 minus negative 2 squared. So first we need to start with our parentheses, follow our order of operations. So that second negative 2 squared is really just telling us to do negative 2 times negative 2. And we know that when we multiply two negatives, that makes a positive, so that's a positive 4. So we have negative 2 minus 4. And remember, we don't always have to keep those subtraction signs. We can actually make that addition very easily by using what's called adding the opposite. And that is just when we change that subtraction sign and we add the opposite. So since that was a positive 4, it's now become a negative 4. So remember, adding the opposite allows us to change that subtraction to addition. So now we have a negative 2 plus a negative 4, which combines to give us a negative 6. Number 18, we have to simplify. This is from lesson 74 and 78. So we have 2 root 8 times root 10. Now for these problems, I like to do the multiplication of the radicals first. So remember, we just do the root 8 times root 10, so that gives us 2 root 80. And now we can start simplifying from here. 80 is not a perfect square, but we need to break it up into its prime factors and see if we can pull out any pairs of prime numbers. So we need to come up with 2 factors of 80. We can choose any 2 that we want. I'm going to do 8 and 10. And then let's start with 8 and break 8 down. We can break that down into 4 and 2. I'm going to circle 2 because it's prime. And then 4 breaks down to 2 and 2. And I'll circle those. Now let's go back to the 10 and I'll break that down into 2 and 5. 2 is prime, so circle that, and so is 5. So now we have all of our prime factors. So I'm going to rewrite this as 2 the square root and put all of my prime factors being multiplied together, and I'll put them in order from least to greatest. So we have 2 times 2 times 2 times 2 times 5. And now we need to go through and look at what we have pairs of. So we have a pair of 2 here, and we have a pair of 2 here. So that means they get to come out of the radical sign. So we get to pull out a 2 to represent that first pair of 2's, and we pull out another 2 to represent that second pair of 2's. So we'll pull out these 2's. So we have, first off, we have the 2 that we originally started with on the outside times another 2 that we pulled out. And then we have the other 2 representing that other pair. And on the inside, we just have the 5 left. However, we're not quite done yet. We need to simplify the outside. So anytime you pull numbers on the outside, you have to multiply them together. So on the outside, we have 8 root 5. Number 19 from lesson 56. What is the slope and the y-intercept of the line y equals negative 3x plus 2? Well, fortunately, this is already in slope-intercept form, which is going to make this a lot easier to answer. So if you recall, slope-intercept form is y equals mx plus b. The m represents our slope, so the number in front of the x is our slope, and then the b, the number by itself at the end, is our y-intercept. So going back to our equation, we see that the number negative 3 is in front of the x and in the m spot. So the slope of this line then is negative 3. The number by itself and at the end is 2, so our y-intercept is a positive 2. And that's it. You could also write this as the point of 0, 2. Number 20 from lesson 81. If minor arc CD is 53 degrees, what is the measure of major arc CD? So we can see this is our minor arc, which is 53 degrees. And it's called a minor arc because minor arcs are going to be less than half of a circle or less than 180 degrees. So 53 is definitely less than 180, so that's our minor arc. Now, major arc CD is going to be bigger than 180, so it's all the way around the circle, from C all the way around to D, the long way. We know a circle is 360 degrees all the way around, so that's what we're going to use to help find the major arc. We need to do 360 minus the minor arc, which is 53 degrees, and that will give us 307. So that means major arc is CD is 307 degrees. Number 21, what is the discount for a shirt that costs $43 that is on sale for 40% off? This is from lesson 48 and 58. This is one of those problems that we could use our percent box for to help us solve. So if you recall, we have two columns. We have our percent on the left and our actual on the right. And then we always divide it up into 3 different rows. Our first row is the original, our next row is the change, and our last row is new. Our original percent is always going to be 100. And then we know it's 40% off, so 40% goes into our change. And since it's a discount, our new is going to be 60%. And then we know that the shirt originally cost $43. So that's our actual amount, and we're going to put that under actual and original. So 43 goes there. And then we want to know what is the discount. So we just want to know what the change in the price is. So that's where we put our X. They're not asking us for the new price. They just want to know what the discount is. So I need to use my first 2 rows because that's where I have both pieces of information. And I'm going to pull those numbers out and make my ratio or my proportion. So 100 over 40 equals 43 over X. And at this point, we just cross multiply. So we can do 100 times X equals 40 times 43, which will give us 1,720. Then at this point, we divide both sides by 100 to get X by itself, and X will equal, since this is money, we're going to write our answer as $17.20. So $17.20 is the discount. There is another method we can use to solve this in which we actually just write this as an equation and solve. So we need to find out what is 40% of 43. So what is 40% of $43? Now in math, we know of means to multiply. So we're just going to change that to multiplication. So of 43. And 40%, we want to make that into a decimal because we never want to multiply by a percent. So 40% as a decimal, we just move our decimal point 2 places to the left, and that's going to give us 0.4. So again, all I did was move that 2 places to the left. And now all we need to do is multiply. So 0.4 times 43 should give us the exact same answer. We're going to get 17.2, which is $17.20.